this will be the demonstration portion of our presentation. I have a cutaway sample here of the HiLife valve, and this happens to be a 1/2 inch size. It's a fairly rugged valve. It's a beefy valve, and you can see the thickness of the liner and all. But I wanted to kind of confirm what we had talked about. I started early on mentioning the ball turns on its own axis, and what I'm referring to there is that we have a stem and we have a round ball, and as we turn it, essentially we're not really displacing material because the ball is turning on its own axis. And that makes an ideal valve to be put on dry powders and slurries. Other type valves don't have the capability of doing that, like a butterfly valve, for example. We spoke about this earlier. It's going to displace material. So I wanted you to see that. I also wanted you to see the full liners. There's one section of the liner here, and then over here on the other side. Those actually contain the seats. And then we have a body section in the middle. But all these components are put together and clamped together by the metal body housing, and it forms a seal. So we could actually put fluids through here, and customers do. They put acids and such, so that we would not leak from this valve with the O-ring seals. And that's ideal when you start dealing with dry powders, especially very, very talc-like powders or slurries. It keeps the materials from packing up and building and increasing the torque. So, said earlier, this is a big beefy valve. This is what we call a 3-piece valve. There's actually 3 pieces here. We have a center section and 2 end pieces. 3 pieces. What this allows us to do, this allows us, number one, to put a full port ball inside of in this particular case, to put a 1/2 inch ball with a 1/2 inch bore in a 1/2 inch pipe. Well, the only way to do that is have a bigger body section and allow you to put the ball in there. But it also, in addition to putting a full port ball hole here, it allows us to use heavy wall construction on these ceramic pieces. And so now we've got some rough, tough stuff here that can handle a little bit of bridging, can handle some shock and piping, and also allow this valve to operate. Ceramics, the worst problems we have with ceramics are freezing and cracking. A lot of valves will still work once cracked, but it does do damage. So you want these pieces to be very, very strong. Finally, said earlier about the materials of construction. So all the pieces in this valve, all the white ceramics you see in this, is a zirconia built alumina, and that allows us to have zirconia for strength and compression. Also, the alumina is much better operating with slurries and this sort of thing. It's got greater wear resistance. The ball, in the other case, that is a zirconia ball, stabilized zirconia, and we use that. It may not be as abrasion resistant, but it's strong, because if we do pack and we do have materials bridging in here, we now have a ball that's not going to crack because of the stem, which is or the tang, which is what we're turning the ball with. So we've got a rough, tough ball in there to hold up to the tougher applications. So with that, hope that meets your satisfaction here, and I'll open it up now to any questions that you may have. Thank you.